Hi everyone, today we're going to do the Seasons Lab. The Seasons Lab is just an example of what's causing this, basically the sun to heat up and cool down planet Earth over the course of a year. Right, so for that we have, the main thing we have is our temperature sensor right here. So we've got the LabQuest computer hooked up, we've got a thermometer right here, and if I hold on to it, I mean fairly quickly, you can see it goes up very quickly, so it's very, very sensitive to measuring the temperature of what's going on around it. Our stand-in for Earth is going to be a recycled aluminum can that I found laying around the school building somewhere many years ago. And we've got a little cardboard shield, and of course we've got our good old-fashioned sunshine right here, or lamp, but that's going to work as our sunshine. Right, and so what we'll do is we'll kind of fill in the different things that we have here on our data sheet, just taking into account the different seasons that we go through. So we'll start off with winter, right? So the simulation for winter means that we're going to cover up 3/4 of the Earth. So what we do for this is we stick the temperature probe down inside of Earth right here, right? We have Earth kind of sitting on its side. Be good for the camera. And then what we'll do is we cover up most of Earth with the shield. That's kind of representing the amount of sunlight that normally we get. And then we point the sun directly onto the planet. And we'll wait a little bit of time and see what happens to the temperature. We'll see if the temperature goes up very much at all over the next couple minutes here. All right, so time is up for the first reading about 2 minutes later, and well, look, it's gone up to 22.2, so that's definitely an improvement. So 22.2. All right, so that's simulating a little bit of time under winter weather exposure. Then we'll wait another 2 minutes and see if the temperature goes up at all. Sometimes it doesn't even go up very much at all. Oh, wait, it just went up a little bit. Because we still, Earth, our simulated Earth right here, it's still mostly shaded. It's not getting very much sunshine at all as time goes on. 2 minutes on, and okay, look, it's gone up almost a whole nother degree. So it's 23.0 degrees. Now we'll move to spring. All right, so for spring on our sheet right here, what we'll do is we're going to uncover it so half of Earth is basically uncovered. And what this does is it simulates one of the equinoxes, spring or fall equinox, where the sun, basically the sun's rays are directly pointed right at the equator of the planet. So what happens is half the planet is getting sun, half the planet's getting dark. So there's equal amounts of dark and light. So literally, if you were to time it, if you were to be at home on an equinox and you were to set a stopwatch and say, okay, it's the sun rose right now, and run the stopwatch until the sun sets, it literally would be exactly 12 hours, right? So that's what we're going to mark down for this one. So in 2 minutes, we'll see how much the temperature rises. Another 2 minutes into our experiment here, and we are at 23.7. 23.7, so it has gone up by 0.7 degrees, maybe 0.6 because it changed to 0.1 right at the very end there. Next, we'll keep it for another 2 minutes in springtime mode, and we'll see 2 minutes later, has the temperature changed? I'm willing to bet it already has gone up a little bit. 2 minutes later, and we're checking to see what happened with spring. 24.1. Excellent. So our temperature is definitely going up. Now, what we have to do next is we have to switch fall and summer because of the way our setup is here and everything. So what we'll do is we're going to do fall, which is also half shaded, half lit. But if you remember, fall comes after the summertime normally. So it kind of, it's warmer. If you've ever noticed, fall is definitely warmer than spring. And so what's happening with that is it's kind of, it's because of how much sun we're getting. If you think about the fall, right, we've just had 3 months or more of direct sunlight pouring on us in the northern hemisphere. So the rocks, the air, the water, everything is all heated up over the course of those months. So if you ever notice, like in the fall, it's definitely warmer in the spring. My example I always like to give students is in the fall, right, you go to, let's say, a football game, and you might be very comfortable wearing just a sweatshirt or something like that, right? for the same amount of sunshine in the spring, right, it's not nearly as warm often. I mean, definitely you get warm days, don't get me wrong, but in general, it's not nearly as warm. In fact, the example I like to give here is if you've ever gone to Hershey Park, springtime in the park, it's often freezing. I mean, I remember taking my kids to springtime in the park, and it was so cold, they would literally wear snow pants and jackets and hats and gloves and beg to go home because they're like, it's too cold to be here and everything like that. Because spring happens right after the winter, where we've just had months and months and months of all the rocks, the air, the water, everything cooling off. So there's this thing called seasonal lag that happens between them, right? That's why spring tends to be, in general, cooler than fall for the same amount of sunshine that we're getting, right? And so that's why we're doing fall now. And in fact, it's time already. We're going to do our first fall reading, which is going to be 24.4. All right, so we've definitely increased temperature-wise a little bit here, and in 2 minutes we'll check and see how we did for our last reading in fall. For our final fall reading, 24.4, it stayed the same, which is not surprising at all because we have the same amount of sunlight going on there. Then what we'll do is we'll take our final readings, which are going to be for summertime. So this one, the sun is pointed directly at the northern hemisphere of Earth, simulating for us, no shield at all. So we'll come back in 2 minutes and see what the reading is. And summertime reading number 1, 24.6. All right, you can see that the sun is heating everything up. Now, it won't be quite as dramatic as in the winter or some of our earlier readings because now we've had, in our case, simulation of months and months of sunlight pouring on us. So we'll take one last reading and we'll see if we can get the temperature to go up at all with more direct sunlight. Hopefully we can get at least a little bit of a degree change. 2 minutes later, and there you have it. Oh, we've gone up 0.3 degrees already. So it's just showing you the more sunlight you get on the planet Earth, the more it heats up.